quiet during the recording?
And it's recording. Okay.
No.
So.
Oh my god. Anus. They're gonna hear that, dude. YouTube's gonna demonetize you.
This is back to something we did in Calc A. We're just doing it with parametric equations. We're looking for the horizontal and the vertical tangent lines. So in a parametric equation where you have x is equal to f of t and y is equal to g of t, or as I kind of sometimes like to say, you have x1 of t and y1 of t, which is sort of how you're going to see it in your calculator. This is kind of the calculator format. Desmos, just so you can have record of how to graph it in Desmos, you actually literally do an ordered pair where you put x1 of t, comma, y1 of t, and then just press enter and it starts to graph and it gives you all the t options. But in any case, your horizontal tangent occurs when, you can probably anticipate this, when what's true?
dy equals 0.
Close. dy over dt is equal to 0. And then vertical, dx dt is equal to 0. It's worth pointing out that if both dy dt equals dx dt equals 0, there is neither tangent. And you may have to look at the graph a little bit more carefully to see what happens. Other things that happen in other cases are where after you do this, you may also want to check dy dx and just see what you know about that. Because, for instance, if you take a derivative dy dt, you have dy dt equals something like x sine x, and if you have dx dt is equal to x cosine x, it may appear as if there's a derivative at 0 in both of those. But what you actually would really want to check is when you divide the two of them out, dy dx would be equal to tangent x. Tangent x, that is equal to 0 at x equals 0. So there is a horizontal tangent at 0, but it's because the combined derivative has that, not because each individual one did. So in cases where you have a cancellation happening when you take the derivatives and divide them by each other, like a clean cancellation, just check what happens at that point. There is one example on the homework that does that. The answer key does not talk about or explain this, and it just was kind of up to me to come up with why is it that we are allowed to do that, or what is happening. And again, my explanation is that here I know that there's a place at x equals 0. Here there's a place at x equals 0. By the rule before, we can't analyze and say definitely that there's a tangent line at those places as that. But when I divide the two, I get a derivative of tangent x, and I know that tangent x is equal to 0 at x equals 0. So that's a thing. I also shouldn't put x here, or x's here. I should put t's. That was very, very poor. None of you saw that. Yeah. So we're going to replace all those x's with t's. There we go. And then at t equals 0, realize that may not be the origin. Depending on what your original functions are doing, that could be any other place as well. Okay, we're going to work through an example of this. Find vertical and horizontal tangents. I tend to do vertical first because it's x. For x of t is equal to 2 cosine t minus cosine of 2t, and y is equal to 2 sine t minus sine of 2t. Let's just do y of t to keep consistent. I'll use this to kind of separate it out. Actually, that was awful. And we're going to do that on a domain restriction of, let's do interval notation, on 0 to 2 pi. Including 0, not including 2 pi. A couple of your homework problems have domain restrictions, a couple don't. And sometimes when they don't, a domain restriction is implied because of the domain restriction of the function itself. So for instance, if you see a radical or a natural log, you know that you can't be left of 0 on any of those. Just be a little bit aware of that. Okay, so vertical, we're just doing a derivative of both. So let's do dy dt. And I would implore you to use the notation dx dt. I'd implore you to use that instead of x prime of t. It's just a little bit better and more consistent with how you're doing the rest of it. This is going to be -2 sine t plus 2 sine of 2t. And dy dt is equal to 2 cosine t minus 2 cosine of 2t. Okay, we're solving each of those equal to 0. Couple of general rules. And as I talked to my good buddy Nick Franklin, we both agreed to kind of reiterate, don't ever divide by a variable expression. Don't do it. You do that, you're going to lose possible roots. And here it's possible solutions. What you want to do, and let's see if you guys kind of remember this, how do I deal with a sine t and a sine 2t in the same problem? Even better. It's not necessarily worrying about where they're equal, because that's a little double angle identities. Double angle identities should now be ingrained in your soul. -2 sine t plus 2. Sine of 2t is what?
Sine 2 sine t.
2 sine t cosine t. Yes, you need to know those. Factor. I'm going to pull out a 2 sine t from both. I end up with 2 cosine t minus 1. And I have sine of t is equal to 0, or cosine of t is equal to 1/2. On 0 to 2 pi, that means t could be equal to 0. T could be equal to pi. Cosine of t is 1/2 would be t is equal to pi over 3, or on 0 to 2 pi.
7 pi over, or no, 5 pi over
5 pi over 3.
Yeah, there we go.
Quadrants 1 and 4. Okay, next let's do the cosine one. Also worth doing because this requires the cosine double angle identity, and you have 3 of them. So, discussion that we had this morning, he's now teaching this to his pre-calc accelerated kids, and they're all complaining because they don't know when to use which identity of the 3 possible ones you can use for cosine. And we're talking about how in Algebra 2, one of the big concepts that you have to do is you have to be able to anticipate what the problem requires and pick what you need based on that by looking a little bit ahead. Which of the identities is going to make sense to use here? Yeah, the one that has cosine squared but not sine squared, right? You got 3 possible ones, starts with cosine squared minus sine squared. So of those 3, that's not cotangent, it's cosine t, we're going to do 2 cosine squared t minus 1. And because we're setting that equal to 0, I can cut the 2 out and say that that is, I'm going to switch some of the signs around, positive 2 cosine squared t minus cosine t, distributed to be plus 1, but we divide would be minus 1. See if we can factor 2 cosine t, 1 and 1, cosine of t, minus 1, plus 1. And I get cosine of t, I keep wanting to write cotangent. Yeah, cost is equal to negative 1/2, or cosine of t is equal to 1. And that would happen at t is equal to, so negative 1/2 for cosine is going to be the, yeah, so 2 pi over 3, 4 pi over 3. Cosine of t is equal to 1 at
0 and 5.
t equals 0, yeah, just 0. I'm just going to put comma 0.
Why can't you put 0 and pi? Because pi is negative.
See the issue?
What?
At t equals 0, you have both a vertical and horizontal tangent, which actually means you have neither. We go back up here. We can't, both dy dt and dx dt equals 0. Neither tangent exists there. Coming back here, you could look at this and try to simplify and work the division around, but that's more than you probably need at this point. So it's pretty safe to say that when I want vertical tangents, we're going to exclude 0. At t is equal to 0. Sorry, not t is equal to 0. I just said we're excluding that. T is equal to pi. T is equal to pi over 3. And t is equal to 5 pi over 3. The question asks you to find the points. So each one of those now gets to be plugged into the original function. T equals pi means x is equal to, it was, if you guys look back, 2 cosine, so negative 2
So it's just 1.
minus cosine of 2 pi is 1, so negative 2 minus 1, that should be negative 3. And y would be equal to sine of pi is 0. I think y is just equal to 0. Then underneath that, x is equal to cosine of pi over 3 is 1/2, so 2 times 1/2 is 1, minus cosine of 2 pi over 3 is negative 1/2. So this is actually plus 1/2. So that's 3/2. Y is equal to, plug in pi over 3 in for cosine, for sine. Sine of pi over 3, root 2 over 2, so you have root 3 over, so it's times 2, so it's just root 3, minus sine of 2t, so sine of 2 times 2 pi over 3, it's still going to be the same, so minus root 3 over 2, you get root 3 over 2. Finally, 5 pi over, isn't this great flexing of your like trig muscles?
It's literally all.
I don't know if it's literally awful. I don't know what that would be though. 1
Metaphorically.
minus cosine of 10 pi over 3. So 10 pi over 3 is really 4 pi over 3. And 4 pi over 3 is in quadrant 3, where cosine's negative. So it's negative 1/2. But it was positive plus, so this is still 3/2. And then y would be equal to 2 times the sine of 5 pi over 3 is negative root 3 minus see, sine of 2t, so 10 pi over 3, so again 4 pi over 3, sine's negative. This would be plus root 3 over 2. So this gives me negative root 3 over 2. And then I would just take all this and kind of put the order pairs together. So negative 3, 0. 3/2 root 3 over 2, and 3/2 negative root 3 over 2. And that was only vertical tangents.
Miss Charlie, you look like a DJ with those headphones on.
Thank you.
Can we request a song?
You have horizontal tangents at t is equal to 2 pi over 3, and t is equal to 4 pi over 3.
This actually might be the worst thing ever.
So you're going to like the ones that don't have trig for obvious reasons. But let's plug in this. So 2 pi over 3, we have 2 cosine of 2 pi over 3. So x is equal to 2. The cosine of 2 pi over 3 is negative 1/2. So 2 times negative 1/2 is negative 1. Minus cosine of 4 pi over 3 is negative 1/2 as well. So that'd be plus 1/2. We get negative 1/2 for x. Y, plug in 2 pi over 3. Sine is root 3 times 2, or root 3 over 2. So that minus sine of 4 pi over 3 is negative, so negative root 3, but we have plus, so plus root 3 over 2. This should give me 3 root 3 over 2. Finally, x is equal to cosine of 4 pi over 3 is negative 1/2 times 2 is negative 1. minus 8 pi over 3 is the same as 2 pi over 3. 2 pi over 3 is a negative 1/2, so minus a negative 1/2 would be plus 1/2, still get a negative 1/2. Then y is equal to 2 sine of 4 pi over 3 is root 3 over 2. Nope, negative root 3 over 2. So this is negative root 3. Minus the sine of 8 pi over 3 is the same as the sine of 2 pi over 3, which is positive. So we're minusing a root 3 over 2. And we get negative 3 root 3 over 2. I like these answers because they seem to be somewhat reflective and they kind of make sense. They're not different from each other too much just by signs. So my horizontal tangents occur at negative 1/2. I'm just going to do plus or minus 3 root 3 over 2.
Imagine stumbling upon this video on YouTube. Imagine having to do this. I can't imagine that. Just watching this video.
Finally, no, I'm going to go Desmos here. It's worth checking this just to see what this looks like. So we're done with the problem, but let's open up Desmos and actually do graph this.
Mr. Elliott, will
Yeah.
all of these be as extensive as that one was?
Extensive, all? No. That's about as complicated as they get. But wouldn't you rather I give you a complicated example to work in class than the simple one?
No, I know that I.
You just discouraged me from ever pursuing a math major of mine.
You know,
I'm not even gonna get my GED now.
if that problem discouraged you from that, then there's really not much I'm going to be able to do. No, don't you dare.
I think that showed up in the old recording. Is Caroline gonna hear it?
She'll hear it. She'll know exactly what you guys are doing.
Yeah, thank God Caroline's not here.
Caroline sucks. Boo.
Table in front of the last sign.
Well, now I'm excited. I'm going to watch this video now that it's on Tuesday.
There we go. Okay, so
Well, actually, now that's just such a mean Tuesday.
there we go. If you kind of graph where we had the different points down, you should see one here. Hang on, guys. Do you see 3 places where there are vertical tangents?
Yeah.
Do you see 2 places where are horizontal tangents?
I see the fucking butt.
Hang on, guys. Do you see why when we start, which is right here, you're not going to have a vertical or horizontal?
Yeah.
This is
Okay.
chaos.
This is
This is cusping everywhere.
Okay, homework.
This is a fucking butt, dude.
I thought we were gonna get anything wrong.
You do, and this.
I'll do one, not both.
This is not a negotiation.
Well,
Not what you're gonna win.
it just turned into one.
Final offer.
You made